Good afternoon, everyone, and welcome to this lecture. Electric potential energy is the topic or discussion, and we had done some question in the previous class. In the previous class, we had found out the potential due to different type of charges at the different points. Do we remember? We had used the formula of potential due to a point charge K Q by R. Do we remember those questions? Yes or no? We found out the potential due to more than one charges at some point. Do we remember those questions, everyone? Or shall I give you more? Remember
Yes,
those
sir.
questions? Okay, so moving ahead, now we will move on to the concept of electrostatic potential energy of 2-point charges. So you can write electrostatic potential energy PE of 2-point charges. Now remember, if there is only one charge and no other charge in the universe, that one charge cannot have potential energy. But if you have at least two charges in the universe, you will have the potential energy of that system. And how much potential energy it will have? Let us suppose that the two charges are Q1 and Q2, and they are separated by a distance of R. Now this is a system of two charges and two charges. The system of two charges will have electrostatic potential energy EPE. We call it EPE. We call it electrostatic potential energy, or I can call it as U. The electrostatic potential energy of this one and two charges. One charge is one, charge number one. Electrostatic potential energy will be given by this formula. You can call it K times Q1 Q2 divided by R. K times Q1 Q2 divided by R. Now this electrostatic potential energy can be positive. This electrostatic potential energy can be negative. Now can you tell me when is this potential energy going to be positive and when is this potential energy going to be negative? Yes, my dear friends. When is this potential energy going to be positive? When is it going to be negative? Remember, I told you about the electrostatic potential. If the charge is positive, it creates positive potential. If the charge is negative, it creates negative potential. But electrostatic potential energy depends on two charges. There must be two charges. Can you tell me when is this energy going to be positive and when is this energy going to be negative? It's a multiplication of two charges. It is a multiplication of two charges. Yes. This energy will be positive when it will be positive when Q1 and Q2 are of same sign. If they are of the same sign, that means both are positive. Positive multiplied by positive is positive. Both are negative. Negative multiplied by negative is also positive. In that case, the electrostatic potential energy will be positive. Do we understand this?
Yes, sir.
Then can you tell me when is this electrostatic potential energy going to be negative?
Q1 and Q2 are of different sign.
Are of opposite sign, different sign, whatever you call it. That means if one is positive and the other is negative, this electrostatic potential energy is going to be negative. Do we understand this, everyone? Can I have raise hands from all the boys and girls that we understand this?
Yes, sir.
Boys, do we understand this? Okay, this is how we find out the electrostatic potential energy, and it is very simple. Two positive or two negative, it will be positive. one positive and one negative, it is going to be negative. I hope everyone understands this. Everyone noted this down as well. Yes or no?
Yes, sir.
Well, this is the electrostatic potential energy of two charges. But imagine what will happen if we have more than two charges. If we have more than two charges, then how will I find out the electrostatic potential energy of the entire system? Tell me, how will I find the potential energy of the entire system? For more than two charges, for more than two charges, for more than two charges, we find electrostatic potential energy, that means U, of all pairs, of all pairs, and add them. So you understand the meaning of pairs? We will have to create pairs. Two charge make a pair. Find out how many pairs are there, and then add those energies together. Do we understand this?
Yes, sir.
Find out the number of pairs. So let us start with a question. That question will help you in understanding what I am talking here. Let us suppose that I have three charges. I have three charges. This is plus Q. This is plus Q. And this is minus 2Q. And this is an equilateral triangle whose edge length is A. This is an equilateral triangle whose edge length is A. I hope we understand this question. This same question can come in your examination hall. Edge length is A, and we have three charges arranged on the vertices of an equilateral triangle. Can you find the electrostatic potential energy of this system? What is the electrostatic potential energy of this system? And I will give you 2 minutes to note this, to solve this. 2 minutes you have.
Sir,
Yes, bacha.
minus KQ square by A.
Minus KQ square by A. How did you get it? Let let me give you 1 more minute for everyone so that they can also understand what we are talking. Okay, so how are we supposed to do this? We are supposed to find out pairs. How many pairs are there? This is one pair, pair number one, Q and Q. This is pair number two, plus Q and minus 2Q. And this is pair number three, plus Q and minus 2Q. There are three pairs. Do we understand this? Yes or no? So we can just find a pair, the energy of pairs and just add them. What is the energy of this pair? Pair number one. Pair number one, what is the energy? That will be equal to K Q square by A. Yes or no?
Yes, sir.
What is the energy of this pair? Pair number two. Q into minus 2Q. So it becomes minus 2Q square. So minus 2K Q square by A. That becomes the energy of this pair. Yes or no?
Yes, sir.
What about the energy of this pair? Plus Q minus 2Q. So it becomes minus 2K Q square by A. How do I get the final answer? We just need to add up this. So I think you will get minus 3KQ square by A. Yes or no?
Yes, sir.
How many of you got this answer? Please raise your hands. Boys? So the energy of the system is minus 3KQ square by A. Do we understand this?
Yes, sir.
Now, sometimes this question can be asked in a different way, beta. So just remember one small important note. They might ask you the energy or the work done in assembling the system. Work done in assembling the system. So just remember work done in assembling. So I'll just give you a note. Work done in assembling the system. When I say assembling the system means bringing these charges together by the electrostatic force. If you just remember one, the rest of them would come automatically. Work done in assembling this system by the electrostatic force is negative of the energy of the system. If you just remember any one of this, because I don't know what they are going to ask. There are four things that can be asked here, four types of work. Work done in assembling the system by the electrostatic force. The second thing they can ask you is work done in assembling the system by external force. So it will be negative of this, so it will become energy of the system. Now this will be same as work done in dismantling the system. You understand the meaning of dismantling, taking them away. work done in dismantling the system by the electrostatic force, and this will be equal to work done in dismantling the system by external force. So the only difference between all these questions are a plus or a minus sign. Do we understand what I am telling you, bacha? So if you can remember any one of these, you can find out the other three. Any one you will have to remember. I'll give you a minute to note it down. Have you noted it, bacha? Shall I give you the next question? Shall I give you the next one, beta?
Yes, sir.
So now this is the question coming onto your screens now. You have a system of 4-point charges arranged in this fashion. The first question is you have to find out what is the energy of the system. The second question is what is the work done in assembling this system by an external force. I'll give you 2 minutes to give me the answer. Just bacha, are we getting any answers? To find out the energy of the system.
Minus 4k q square by A, sir.
Have you taken into consideration all the pairs? All the pairs have you taken into consideration? I hope you understand the meaning of pairs. Pairs of two. Have you taken all the pairs? How many pairs are there? How many pairs of charges are there, beta? Yes, tell me. How many pair of charges are there? Two. Two pair of charges are there. Two pairs.
6
Six pairs.
minus 2k q by square.
So it's minus 2k q square by A.
This is pair number 1. Pair number 2. Pair number 3. Pair number 4. So I have 4 pairs of plus q and minus q. I have 4 pairs of plus q and minus q. Yes or no? I have 4 pairs of plus q and minus q. So I can just multiply it by 4. One is positive charge, the other one is negative charge. So all are having minus energies, negative energies. Minus 4kq square by A. Do we understand this? These are the 4 pairs of plus q and minus q. Do we understand this?
Yes, sir.
Someone said 6 pairs. I can only see 4. Where are the other 2? I can only see 4. Where are the other 2?
Sir?
How many pairs you said? Someone said 6 pairs. I can only see 4 pairs. Where are the other 2?
So diagonals?
Sir, diagonals. Yes, sir, diagonals. So this is pair number 5. And this is pair number 6. Now pair number 5 is plus q and plus q. So energy is positive. Pair number 6 also, it is minus q and minus q. So the energy is positive. So I just multiplied this by 2. What is the energy of any one pair? The energy is same. Both the energies are positive. K into q square. What is the distance between these two charges? It is root 2a. This is your final answer. Minus 4kq square by a plus 2kq square by root 2a. That is the energy of the system. Do we understand this?
Yes, sir.
Why you were not getting this answer? Okay. So remember, this is the way you must find out the electrostatic potential energy of any system. Everywhere. We have understood this, yes or no?
Yes, sir.
The next question was, what was the work done in assembling this system by an external force? So what is the answer for that part? Can you tell me the answer for that part, Bacha? What is the work done in assembling this system by an external force? Yes, Bacha. Can you tell me the answer for this part? Yes, Bacha. What is the work done in assembling this system, beta? By external force. And what is the answer for this one? I told you that concept, yes or no? The work done in assembling the system by the external force beta is equal to the energy of the system. So whatever answer we have got, that is the answer for this one. Do we understand this? Yes or no?
Yes, sir.
Everyone understands this? Can I have raised hands from everyone that we understand this? Okay. Now sometimes instead of asking you the energy of the system, they may ask you energy of a charge, and I will just give you that question that has come, and then we will solve that question, and probably we will try to understand it from the question itself. I would be very happy and very pleased if she can give me the answer for this one. I hope everyone is listening here. Boys,
Yes.
are we there in the class? Okay, now this is the question that came in one of your exams. Each corner of a cube has a side length of L, so it is the same question of a cube. Okay, let's not do this first. Let me change this question from cube to square. Square. Let me first change it from a cube to a square. Each corner of a square of side length has a negative charge minus q. So let us first solve it for square. The electrostatic potential energy of a charge q at the center of the, instead of a cube, take it as square. So since I have changed the question, the options are no longer valid, but you can still give me the correct answer. So I've changed the question from cube to a square. Can you tell me the answer of this one? I'll give you 2 minutes. Now remember, bacha, whenever they ask you potential energy of a point charge, so what you got to do is this question that I have given you is similar to the question that we had done on the very first day. On the very first day, we had done a question where you had four charges placed at the vertices of a square, and I asked you to find out the potential of the point O. Yes or no? Do we remember this question? Now, what has changed in this question is instead of this point, they have put a negative charge here and they are asking you what is the energy of this charge. So remember, what is the relation between potential and potential energy? What is the relation between potential and potential energy? I have already told you that relation between potential and potential energy. I will again take you back to that point. I have already told you the relation between potential and potential energy. Potential energy, the difference in potential energy is Q times the difference in potential, or you can write this formula in this way also, beta, that your potential energy will be equal to Q multiplied by V. So if you want to find out the potential energy of a point charge, you multiply that point charge by the potential at that point. Do we understand this? Yes or no? So you can go back and write this formula also there. The relation between potential and potential energy. We had written it in terms of potential difference, but you can also write it taking the potential at infinity to be zero. You can write the same relation between potential and potential energies. Now coming back to the question that I asked, now can I get an answer for this one? You have four negative charges minus Q placed at the vertices of a square of side length L. Can you tell me what is the potential energy of a positive charge Q which is placed at the center of the square? And I'll give you 2 minutes to do this. Yes, do we have an answer? Shall I do it? So, how to do this? This is the question, bacha. You have got 4-point charges. Minus Q, minus Q, minus Q, and minus Q. And the edge length is L, which is given in the question. You have to find out the electrostatic potential energy of a point charge which is placed at the center here. So what you got to do, you have to find the potential of the center. Let me call this as O. What is the potential of the center? All the 4 charges are equal. The distance is also equal. So I multiply this by 4. The potential of any one of the charge will be minus kq by the distance of the charge from the center. How much is the distance of the charge from the center? I have told you it is a by root 2. So the potential of point O becomes, minus 4 root 2 kq by a. The potential at the point O becomes minus 4 root 2 kq by a. Therefore, the potential energy of the charge becomes, you just multiply it by charge, minus 4 root 2 kq square by a. That is the answer that I was looking for. Why is it taking so long for you to get this? Is it so difficult? Anyways, please note down the solution. I'll give you 2 minutes. Once you are done, please let me know. Have you noted it down, bacha? Have you noted it down, beta?
Yes, sir.
Well done. Then once you have understood this question, then probably you can solve the original question. And the original question was like this. You have a cube of edge length L. So now you have 2 minutes to solve the original question. How will you solve the original question? How will you solve the original question? Remember, the length of diagonal of a cube, the length of diagonal of a cube, and remember this, length of a diagonal of a cube is root 3L, and distance of any vertex from the center, and remember this, the distance of any vertex from the center is root 3 by 2L. The distance of any vertex from the center is root 3 by 2L. I'll give you 2 minutes after this. If you can now give me the answer for this one, I would be very happy. Anyone with any answer, beta? What is wrong? Sir, option C. It cannot be, first of all, positive. So option C is out of the picture, beta. It cannot be positive. So option C is definitely not possible, beta. I don't know how you are getting option C, beta. The option C is the last option which is possible, because all the charges are negative and one of the charge is positive. So the answer cannot be positive. Answer has to be negative. I don't know how can you get a positive answer. Positive answer is definitely not possible. Not in this universe. Maybe in some other universe that you are living, better. I'm very disappointed with the negative answer. I'm very disappointed with the positive answer. It is not possible in this universe. Please come back in this universe. This is a good universe to live in. Answer D is the correct one. That's great. So we have got hope here. So we have 8 charges, a cube has 8 corners, 8 charges. What will be the potential due to one charge? Potential due to one charge will be minus k cube divided by the distance. Distance is root 3L by 2. This is the potential created by one charge. I multiply it by 8. I multiply it by 8 and then I multiply it by the charge, and that is my answer. The value of k is 1 by 4 pi epsilon naught. So when I put the value of k is 1 by 4 pi epsilon naught, the correct answer would be D. And that is the correct answer. How many of you got this? Yes or no? Why did not you speak up? Anyways, it is very simple. Remember, one of these question will land up in your paper, and I hope that you are able to do it. We are done with this potential energy concept. The next class we'll move further ahead and see more concepts on potential. We will try to see the relation between electric field and potential, and how you can find out electric field from electric potential. That's coming up in the next class. Take care. God bless all of you. Bye bye.